really something very special. Just clear this out of the way. Okay. Do we have anybody in the audience who speaks German? Yes. Oh, that's interesting. Well, who said 9? You do. A bit of squeaking going on. Okay, our next act, you may be familiar with him. His name is Felix, or Felix, and he's going to be presenting something very special. Something. Actually, I might try and present this in German because I'm getting a bit bored with English. Do you want to have a laugh at how bad my German is? Yes! Yes? Okay, I'll try. No, seriously, I've got to make this last another 5 minutes, so you've got to listen to the German. Okay, ich hab eigentlich die Nase voll mit Englisch, also werde ich versuchen, irgendwas auf Deutsch zu sagen. Jetzt kommt Felix aus irgendwo. Er heißt, wenn ich das richtig verstanden habe, ein Mathematiker. Nee? Und er präsentiert jetzt irgendwas mit Logik, Mathe, Naturwissenschaft und Magie. In English, not that I described that particularly well in German, our next act, Felix. Oh, that's terrifying. This gentleman is a mathemagician. So he combines logic, maths, science, and scariness to bring you his very special mathemagicianness. Yeah, I'll just leave you to get on with it. Okay. Yeah.
Peter wasn't allowed to give a talk today. I am. Let's talk about mathematics. I'm sure you have already some experience with math during your school time, maybe. May I ask you who had some good experience with math in school? No. Okay. Some bad experience? Okay, who did not really care about math? Who have ever visited school? Maybe some of you are already dead, but I said that I would talk about mathematics. But don't be afraid, in school you usually do not go beyond some simple calculations, which might be boring or not, depends highly on the teacher. I will show you a bit of the beauty of mathematics. I will show you 2 examples, 2 fields of mathematics, and show you the magic, mathemagic. To get started with, we will start with number theory. So please think about a number between 1 and 10. Maybe to be precise, an integer. Numbers are now fractional or fancy like pi or square root of 2. I have to be careful, there's another mathematician somewhere. Okay, so you have an integer number between 1 and 10, yes? Okay, multiply this number by 9. Yeah, so you multiply the number you got at the beginning by 9. Have it? Okay, now take the sum of its digits. So if you have 5 to 7, for example, take 5 plus 7, which equals 12. You have 67, take 6 plus 7, which is 13. Do you have this number?
Yeah.
Okay, now take this number, yeah, good. Subtract 1. That's rather easy, I guess. Okay, now divide it by 2. And finally add 3. Now you have a certain number in your mind. And please think about the letter in the alphabet which comes exactly at this position. So if you're thinking about number 1, it's A. If you're thinking about number 5, it's E. 6 is F. 7 is G. H is 8, and so on. So you have the letter in the alphabet. Now think about the country in the European Union which starts with this letter. So you got one? Please think about the second one.
About what?
About a second country which starts with the same letter. If you have problems with that, think about the financial crisis. 2 countries very popular. One because it needs money and the other one does not want to give money. In And if you take the country which has as many letters as the number you add in the end, it's the country I'm from. You might wonder, I hope at least you're all thinking Germany at the end. You might wonder how I did that, but I'm a mathematician, so I won't tell you. Instead, I will now go to topology. Now, topology, that's something interesting, are two-sheeted coverings. And to get you a short introduction into this, I will present you something from spin geometry. So, that's an electron. The nice thing about mathematics is you can say to a table tennis ball, that's an electron, and nobody thinks you're crazy, because in mathematics can make strange assumptions and make sense of it. Now, suppose that's an electron. If you move it somewhere around and it's at the same position, usually nothing happens. But you can take the electron, do something really fancy, take it back at the same position, and you wonder, well, it's somewhat different. What happened? Well, the spin of the electron is different. Before it had spin top, and after the strange movement, it has spin down. Now, that's somewhat strange. If you wonder how can you do this, don't ask me. I do not care so much about real-life problems. But you can ask a physicist. I think they will be rather happy to answer you. But don't ask a physician. Physician might think that you are crazy. So, we have this electron, did something fancy, changed the spin, but we want to have the spin to have top as in the beginning. So what we can do, well, we could do the same in reverse order, but the problem is we cannot go back in time, at least not yet. So we will do the same fancy stuff again. And something magic happens, it will be exactly the same spin as before. Now what's the reason behind it in mathematical terms? Well, we live in our universe, but the spin lives in a spin universe. The spin universe looks exactly like our universe, but at each point there's spin top or spin down. And if we have somehow a movement from spin top to spin down, and we do exactly the same, at least in the projection of this two-sheeted covering, we go from spin down to spin top. Now, the problem with electrons is you usually cannot see them, and it's not a good thing to visualize two-sheeted coverings. So I thought, how can I visualize to you two-sheeted coverings? Well, I thought a little and thought, but what's a good place to think about? It's the toilet. Yeah, it's very quiet, so you can think. Somehow figured out, well, there's two-sheeted toilet paper. And I want to visualize a two-sheeted covering. So why not try with two-sheeted toilet paper? And in fact, you can do this. Maybe you want to guess what you can visualize with three-sheeted toilet paper? Okay, I'll give you this as an home exercise. But for this I will need an assistant. So, somebody who volunteers? Yeah, thanks, Andreas. Actually, I was hoping a beautiful woman comes now. Okay, your task is to simply hold this and check that I'm not cheating. Now, that's the toilet paper. Now I return it once in clockwise direction. And you see it's somewhat twisted. Before it was spin top, and now it's spin down. You can try a little bit to unroll it, but it's still twisted. You can try it on the toilet next time you want and detwist it. Let's get back again. So, I told you if you do twice the same fancy stuff, you will go back to the same position. So, that was the spin top. Let's spin down. So, if I do this again, it's spin top. It's somewhat strange, it looks exactly the same as before. Well, but I can do a small thing. Be careful and don't rotate it. And it's untwisted.
Oh!
That's magic, isn't it? However, it might happen that you do not have toilet paper. I hope you will know never go into a situation where you do not have any toilet paper anymore. But suppose shit happens and you have no toilet paper. What do you do then? Well, simply take your hand, at least for doing math. So, all of you, please do take your right arm, such that the palm is looking upside. So, now rotate it once in clockwise direction. If you look at your palm, it's rather difficult, but you can look at your neighbor. It somehow looks the same as before, but you can feel it's somehow different. That's your spin down position. So we will do the same again, so please rotate your arm in clockwise direction. So we are back in the same position. Note, it's really a different movement. It's really one, it's not back and forth. So that's a nice visualization of a two-sheeted covering. So thank you very much for assisting me. You can keep the toilet paper as a souvenir. Oh yeah. And thank you very much for your attention.